Hey there, in this video segment we are working with some more manipulations of logarithmic expressions, and this is part 2. So we are going to focus in this video clip on condensing logarithmic expressions. Instead of taking one logarithm and expanding it as much as possible, we're going the other direction. And we are condensing multiple logarithms with the same base into a single logarithm. Okay, so we're going the other way. We want a couple of things when we condense logarithms. We want a single logarithm as our outcome. And we also want to have a coefficient of 1. We don't want to have any other coefficients on our logarithmic expressions. So let's just dive right in and look at some examples. We're going to first start with this example. 1/2 ln of x plus ln of y. So the first thing I would suggest doing is getting rid of these coefficients, okay, because once we do that, then we can combine using the product rule. So recall that I can take this coefficient of 1/2 and shift it and write it as a power of x, and since x to the 1/2 power is commonly written in a different way, I'm going to write it in that way. X to the 1/2 power is equivalent to the square root of x. So this expression here is equal to ln of the square root of x plus ln of y. Okay, so now I have two logarithms with the same base. I can condense them into a single log, and since I'm adding them, they will, in my new log, be a product. So ln of the square root of x times y would be an equivalent expression to what we started with here. Notice that when we're done, we have one logarithm, and there's nothing out in front of this log like a 2 or 3 or a 1/2 or whatever. Okay, so in our next example, we're going to look at this one. 4 times ln of the quantity x plus 6 minus 3 times ln of x. All right, so we are going to take this, and let's first employ the power rule and move this 4 to a power here and move this 3 to a power there. All right, and I'm going to write underneath since we have a little more space there. And I'm going to say that this is the same as ln of x plus 6 to the 4th power minus ln of x cubed. Okay, so now notice I have two logarithms without coefficients, and they have the same base. The base here is e, so I can condense them into a single logarithm. Okay, so I'm going to say that this is ln of, and notice I am subtracting here. So we've got a fraction. The positive part, see the ln is positive here, this argument will go to the top. X plus 6 quantity to the 4th power. And then this quantity down here is negative. See, the logarithm here is negative, so this actually goes down to the bottom, x cubed. And then we're going to just group that whole thing and say that we are finished. One logarithm, no leading coefficient other than 1. Okay, so let's go ahead and look at our next example. And this one we have some fractions with. We can, should we choose to, distribute that 1/3 through, and I think for many of you that would be a good first step in this example. So let's go ahead and do that. Let's distribute that 1/3 to both logarithms. 1/3 times the log base 4 of x minus 1/3 times the log base 4 of y. All right. So as we did before, we can pull this 1/3 and use it as a power. Now recall that anything to the 1/3 power is the same as the cube root. So when we rewrite, we're going to rewrite it as the cube root. There's nothing wrong with writing x to the 1/3 power, but for many people, it's easier to see what we're doing if we use the radical symbol. So this would be log base 4 of the cube root of x minus log base 4 of the cube root of y. All right. So now we have two logs with the same base, and they're being subtracted. So I can condense them into one log with that base. So we can call this log base 4. And since that is a subtraction symbol, we have a division or a quotient in our argument. And the positive logarithm goes on the top, the cube root of x. And the negative logarithm goes on the bottom, the cube root of y. Okay, and we can call that good, or we can write this using our radical properties as just one radical. Log base 4 of the cube root of x over y. Sorry about that. Okay, so either one of these are correct answers. Just recall that they are equivalent. All right, last example here. Now we're going to look at this one. So let's move this up and move this down so we don't have stuff from the prior problems. Okay, so I think that probably helpful for most of you to distribute that 1/2 through here. Okay, and perhaps you are at the point that we can actually distribute and employ the power rule at the same time. Let's try that. So if I were to distribute this 1/2 to this log base 5 of x, I could think of it as log base 5 of x to the 1/2 power, right? And then if I were to think of this going to this log base 5 of y, this would be 1/2 times the log base 5 of y, which we could write as log base 5 of y to the 1/2 power, right? And then we can employ that power rule here to take that 2 and write it as a power. Log base 5 of the quantity x plus 1 squared. Okay, very good. So let's go ahead and condense, or maybe take an intermediate step and write these as radicals. Okay, log base 5 of the square root of x plus log base 5 of the square root of y minus log base 5 of x plus 1 squared. All right, so now we have 3 logarithms. They each have a base of 5, so I can condense them into a single logarithm with a base of 5. I've got 2 positive things, and I have 1 negative thing. So those positive things are going to go in my numerator, the square root of x times the square root of y, and the negative thing will go in my denominator, and that is x plus 1 quantity squared. And we can leave it like that, or we can combine these radicals together, and either way is correct. Log base 5 of the square root of x times y all over x plus 1 quantity squared. And that's all she wrote. See you next time.